Yeah, uh, let me introduce that today's last speaker, Dr. Anand Mukhopadhyay. Dr. Anand is a senior engineer on education team at MathsWork, Bangalore, where he has been contributed since August 2020. He collaborates with academic institutions and educators to enhance their curriculum, research, and initiatives. Before joining MathsWork, Anand completed a PhD in neuromorphic computing applications at IIT Kharagpur. He is MTech from NIT Rourkela and BTech from ECE background, which is from Techno India College of Technology. Anand has co-authored approximately 35 research articles in various journals and conferences. His area of focus is artificial intelligence and its applications. With this short, brief introduction of today's speaker, I request Dr. Anand sir, please go ahead with your session.
Thank you, Dr. Ravi, for the invitation and for the warm welcome. And I hope I feel 140 is a large number, considering this as the last session and also a weekend, Saturday. But yeah, thanks everyone for joining.
In between, they will join, sir, because of the floods are there now. Some rainy seasons is there. Their internet issues are also there. They are joining in between.
They're joining in between. Okay. And today's topic, as you can see here, so I will be discussing on aspects related to AI. So there was a question, the last question in the previous talk was related to AI, how it can be used. So some of those aspects I will discuss in the area of energy forecasting and demand management. So these are very important topics, not only recently, but for many decades, because we need to conserve our energy. We need to use renewable energy and save all the non-renewable, which is in limited number. And what are the ways which can help us to do that? So that is a very vast topic, and AI can play a role in different ways wherever data is involved. So you heard from Dr. Sangvi also, we need to understand how we can collect data, because AI is all about modeling the data. There is some amount of data analytics also involved there. So there are many things here. So the work that I will discuss here, it's done by many people, many math workers, while working with different customers, the actual customers in the sense the industry people who are in the energy sector. So they need to optimize their model. So whenever we are talking about demand management, it's about how we can optimize and make it more efficient. And energy forecasting is like how we can predict how much energy will be required at a certain place, so that we can save the energy there as well. Okay, so this is the topic that we will discuss. And you see a picture here, like most of the industries, what they do, they want to make an application out of it. So application in the sense, this is a kind of dashboard where they can see the forecast, so they can predict on a daily basis what can be the energy requirement in the next day. And these kind of things are there are many complexities in the sense, because it is not like we need to make the system auto updatable, if I say in the other way. So if we make this system for a set of data, then we can get some specific results depending on that. But this is such a sector where the parameters which are involved in training the such AI models may change because of many factors. So we need to assess, we need to have that domain knowledge also, like which are those parameters and how we can auto tune the entire framework, so that we can get the best possible prediction. So ultimately, what AI is doing, AI is helping us to predict something, but how can we minimize that error? So the better we can do on those aspects, the more energy we can save there. So with that, so this is the broad outline. So I will go through some introductory slides and then talk about energy forecasting and artificial intelligence, and finally conclude with some resources which you can take away. So this will be just like a talk for you to understand and try to relate to your work. There are many of you here who might be working in different projects in this broad topic of climate, to save our climate and the sustainable energy. So if you can relate certain things from here, it will be very nice. And with that, so some of the learnings that I want all of you and that I want to discuss today is primarily on these three aspects. So one is, what is this load forecasting, and who is benefiting by doing it, why we need it, okay, and then how to leverage domain expertise in the AI workflow using MATLAB, and how to deploy algorithms seamlessly to enterprise scale solutions and integrate with a dashboard. So these are the 3 points on a high level when we talk about actual industries working on problems. Okay, so they need to start from understanding the problem. So if the problem is load forecasting, so it's not only the industries who are benefiting, but it's all the customers or all the consumers, I would say. Okay, so if you can save energy at one place, then there will be less load sheddings in some other place. For example, we saw there was flood today, and the professor mentioned that still he was able to deliver the session because he had the electricity, the connection did not get lost. Okay, so maybe in the background, the electricity providers, they have used some of the workflows pertaining to energy management optimization, okay, which is helping to provide energy at all places in difficult scenarios as well. Okay, so that's what is load forecasting. If we can forecast how much load is required at different regions, okay, it may vary from region to region, it may vary from time to time, so it may depend on the weather, it may depend on the, you can say, GDP. Okay, what was the previous GDP, what is the economic growth of a particular region, and it may not be a very linear relation also. So it can be very much stochastic also. So many algorithms are also there which needs to be understood, which one to apply, why to apply. So that is about these things. And in terms of AI, not everyone will have an expertise in artificial intelligence algorithms. So that's okay. So if you are an expert in your field, okay, in the sector of the application where you are collecting data, you can leverage some of the workflows, okay, without having a thorough understanding of the AI algorithm. So that's what point 2 talks about. So how you can leverage your domain expertise with the AI workflow. So there are different AI techniques. We will discuss that in a while, machine learning or deep learning. Okay, so how you can use that in those applications using MATLAB. And finally, the final point I will touch upon is like once you are ready with the models, so there are different ways to deploy the algorithms to enterprise scale solutions. So let's look at this diagram. So this looks like a very clean clean society where you are seeing some buildings, car parking, a windmill, Okay, and then also different sources of electricity. Okay, so there are renewable sources as well as the non-renewable sources of energy, and this is about modernization of the grid. So when we talk about modernization of grid, it's a mega trend, and there are aspects like how we can use the renewable energy. So it's like the wind or the solar or the photovoltaic solar cells are there, and the wind, and sometimes the water also. So depending on the region, we have to understand whether this region is suitable for a windmill or not. So for example, so not all regions can make use of the wind energy, or not all region will have the capable or get sunlight to that extent. So for example, in the Cochin airport, so it's like a fully solar powered airport. Okay, because you can get proper amount of sunlight throughout the year, so you can leverage that solar energy, and the entire airport is running on that. Okay, so depending on the region, you need to understand what are the renewable source of energies that we can use there. Okay, so that's a very important point, the choice of renewable energy. And after that, the second important point will be about storing the energy. So it may be that we are capturing a lot of energy at one point of time, but we may not require it, the entire thing to be used at the same time. So we need to understand about storage. So what are it's another research area, like people, what are the efficient ways of storing the energy, what we are collecting, and which can be used later without much dissipation of the stored energy. So these two aspects of renewables and energy storage are there, and this brings out a lot of uncertainty in the entire grid system, because we have to make a balance between this. And throughout the process, like we are generating power, we are transmitting power, and we are distributing it among the different consumers or different places where we need the power. So in the entire process, if you see, there will be lots of data, like terabytes of data involved. Okay, and these are the data that the domain expert will understand. So many different problems will come out, how we can use those data, and how we can work on those to predict certain things. Okay, and with that, there is the regulatory body also involved. So who will also have some guidelines regarding whether things are done properly or not. So which are some of the key aspects when we talk about the grid modernization as a mega trend. Now, from grid modernization, we also hear about smart grid. So smart grid is like area, or you can say a sub area of this grid technology, which focuses on like the power system studies and the compliance, then the grid analytics, and also on the IoT and OT applications. Okay, the Internet of Things and operational technology applications. So these are three different aspects when we talking about smart grid. And today we will mainly focus on the analytics part, because we will talk how AI can be used, and in that way, when we are talking about data, so before AI as well, we need to understand how we can do some data analysis. So you can say data analytics followed by using some AI methods. So that falls under the grid analytics point of view. However, those who are in electrical engineering domain, so most of you might be doing research in power system studies. So there are so many topics there related to that. where you are making using different physical models, different converters, and these and so many things. Similarly, for the IoT applications, how we are using the cloud-based server to do some of the, or you can say, edge processing or on the cloud processing, okay, to save some of the compute power, okay, and communicate between large distances. And operational technology, it will be basically for the industries, okay, to make their operations, day-to-day operations, more functionalized or in a very structured way. So under grid analytics, so if we talk about grid analytics, then there are like things involved, like how to monitor the assets, okay, or asset management. So asset management, you can say, falls under, you can say, maintaining your machines, you can say, in a very simple word. So or predictive maintenance. Okay, so how you can monitor the health of the system, okay, inside the entire scene. There are different systems, so how you can manage or how you can monitor the health of the system. And when we talk about predictive maintenance, it's like a terminology which is like predicting the health of the system, okay, and before the system gets damaged, it can give us some signs. If it can give us some sign that the system is not working properly or may get damaged, so that we can or people can attend to it. So this can save a lot of time in terms of replacing the machine or repairing the machine before it gets damaged. Okay, so developing these models or understanding the remaining useful life of a machine, so that it can be replaced. Okay, maybe a machine may not work after 10 years. Okay, but suppose in such a certain scenarios, if we see it is giving good performance even after 10 years, and after 15 years it gets damaged. So there is no point of just replacing the machine after 10 years if it is still giving the a certain level of performance. Okay, it depends on the product to product. It can be less also. Okay, so that's why if we can calculate the remaining useful life using different algorithms, we can again save on the cost related to the asset. So that falls under the asset management. Then the second thing is on how to assess the grid stability with the OSI SoftSpy plus MATLAB. So OSI SoftSpy, so these are like some third-party tools. So how we can integrate with them to access the data. So the third-party tools which can capture the data from different sensors and perform analytics. So in this field, I will come to that in the later slides as well, but just emphasizing it again. Understanding the data itself is a very big challenge, because it's not just a single sensor which is capturing a data, or there are multiple types of data which are there, and we need to have a synchronize, or we need to synchronize between them so that it can be used further. Okay, so this how we can collect or combine those data for our further analysis. That's a important point. And then coming to the third point on the forecasting. So forecasting or predicting the energy requirement or predicting the price requirement, maybe in a particular region, okay, is the point. So it can be done using conventional methods, like if I say if you are just using data analysis and no AI, okay, then we need a lot of insights from the data, and we need to fit that using some conventional algorithms, maybe a curve fitting kind of thing, okay, which can give us some estimate, or some regression models, you can say. But there are different AI technologies now, which is supporting those regression analysis. Okay, so in those cases, we can use AI to do the same thing and probably get similar results or better results. And probably the reason to look into AI here will be it can help us to scale the problem. Okay, so it's not a problem which is a localized problem. Okay, although this is a problem which is there everywhere in the globe. Okay, so if we are successful in one region, then that same problem or the same solution or similar kind of solution or workflow could be adopted in other regions. Okay, so scaling up becomes very much easier here. So that's the reason we have seen people used AI techniques to forecast the load generation and the prices at multiple places, and how to integrate the forecast models with the grid simulation to improve the system reliability. So that's a very important point. So we want to have reliable data, and it's an iterative process. So so the algorithm which can auto adapt. Okay, so at the end we have to figure out, or we have to make a pipeline. So from that perspective, which can auto update the models and help us to give the reliable results from time to time. Okay, so that's about the energy and price forecasting. And again, we will be talking more on this front. Okay, in today's talk. Now, coming to the next slide, it's a user story. So from a MathWorks customer, so Gas Natural Fenosa, they predicted their energy supply and demand, and the challenge was to maximize the margins in energy trading by predicting available supply and peak demand. So again, the same thing, but it's a company who is supplying the energy depending on the demand. And so these are the places where it's a must for them. Okay, because that directly is pointing to their business. Okay, so if they can maximize the energy savings, it's not only saving the climate in terms of saving energy, but in terms of the profits also. So they were able to get better profit if they save energy. So what kind of solutions they used? They used the MathWorks tools to build and optimize the models that incorporate few things like the historical data, the weather forecast, and the regulatory rules. So these are the three things which are important also. So whatever past data we have, and what is the weather forecast, okay, which is actually kind of a future forecast of the weather. If the weather forecast says like it will become very hot the upcoming year, obviously more energy will be required. People will use more of the electricity for like maybe the usage of fan or air conditioner. So weather forecast is an important thing. Historical data always plays a role, and the regulatory rules. So whatever rules are there with the regulation bodies, they need to follow. So all those things need to be incorporated when they are building or optimizing their model. So as a result, the response time reduced by months, and the productivity doubled, and the program maintenance also simplified. So this is one use case from the industry. Now, when we talk about energy forecasting, so there are different sub buckets. So one is load forecasting, so to improve the system operation planning, market participation, or forecasting the wind, forecasting the solar, forecasting the price. Okay, so what will be, whether the price will increase, it will stay same or decrease. So all these aspects are there, which are again related to each other as well. Okay, and as well are sub branches of the overall energy forecasting. And if we talk about who needs these kind of energy forecasting, so it's like in the entire pipeline. So from generation, transmission to distribution, to the electricity retail energy traders, to all the consumers, all the large electricity consumers outside the energy industry as well. Okay, because ultimately although the challenge or the problem here is very much similar, but it caters to so many people, and to have, and it will have some customized solution also. Although the workflows might look similar, it will again depend on places, and the parameters might change. So you need to also customize these things from place to place. So that's the challenge here. But again, how to simplify those things are something that we want to discuss today. And here, when we talk about load forecasting, there is a nice discovery page also. So if you type, there's a URL provided here in this slide. If you go to that URL, you can learn more about some of the things related to load forecasting, like power companies, how they rely on accurate electricity load forecasting to minimize their financial risk and optimize their operational efficiency and reliability, and the four aspects. So when we are talking about load forecasting, so it will involve four key things. First, about automating the data access from the regional wholesale electricity markets. Okay, so they need to automate the data access so that they can use that immediately when available. Second, how to customize the models using the techniques like nonlinear regression, non-parametric neural network techniques. So these are the AI techniques, you can say, falling under machine learning or deep learning methods. Then how you can calibrate the models with historical predictors, such as weather, seasonality, load, fuel price, and power price. So these are the other factors. Okay, so which is also a kind of contributing to the data. So we need to use take these predictors while we are calibrating or while we are optimizing the model as well. And then finally, once the three steps are done, how we can deploy such things and where to deploy and integrate these load forecasting algorithms into the enterprise system. So these are the four key things when we talk about load forecasting, and which is followed by mainly the power companies, okay, for their business and for saving energy, for optimizing the energy. Now these four steps, if we look further here, it will look something like this. So you see here we are accessing and exploring data. Okay, so there are various sources of data. Okay, it may be in the form of files, it may be in the form of data stores, it can be streamed from certain sensors, or like from the OTs. Okay, and there are different terminologies involved here. So looking into this itself, you may understand that it's not a very trivial task. Okay, there are different forms of data, and after collection, we need to understand how we can use all of them together. Okay, how we can combine them, all of them together in a similar fashion so that it can be used. So that itself is a challenge. So how we can access, how we can explore these data. And after exploring that, the second challenge will be how we can clean the data. Okay, cleaning means how to pre-process the data. So pre-processing the data, analyzing the data during the pre-process step, so that we can finally get the useful information out of it. And once we have that, then we can use that to forecast our models or to use the AI techniques. So only in the third step, we are talking about AI. So after the first and second step is done properly, we can use the AI techniques. We can use the features that we get after the pre-processing step on the AI models, and we can search for the different types of models. So when we are searching for when we are talking about the third point also, there are so many models involved. So that itself is another place where you need to understand which model we should choose or which not to choose. Okay. So there is no fixed answer here. It may depend from application to application, or it may depend from the type of features you are feeding. But finally, that is one place where you need to analyze and at least select some of the models which are apt for the application. And once that is done, how you can optimize that. Okay, so because the third step itself is iterative, so you need to optimize to get the better model. You need to validate in every iteration, and after that, the fourth is the another challenge. So how you can operationalize the models. Okay, in terms of maybe creating a desktop app or creating a web app. Okay, where the application itself is collecting the data and giving you the correct result. And there are dashboards and different enterprise apps. So so another important point here. So in the quote mentioned by company Gas Natural Fenosa. So because we need to rapidly respond to shifting production constraints and changing demand. Okay, because it is the production constraints and changing demands are there. Okay, from time to time, we cannot depend on a closed or even a proprietary solution. So this point is very important because often there will be other companies which can help, for example, Gas Natural Fenosa, to give them a solution or make an app for them. Okay, but if there is no scope to change that thing, okay, that app may not be useful after a few years. Okay, so because there is a change in the constraints, the production constraints, the demands, changing demands, then they have to again make a fresh thing. So that's why the best possible thing what the company thought of is to make a system, okay, using our tools, okay, which will give them flexibility to develop and to update and optimize the models in response to the changing needs. Okay, so if they have developed their own solution, okay, then they actually know how to update it, how to optimize it whenever there is a change or whenever they want to do that update. So that is a very important point here. So how we can do that? So when I was talking about the fourth step, so when we are making an model in terms or deploying it in terms of an app, so what are the so taking this point into consideration is very important. Okay, so how easily we can update it. So obviously it may not be that easy, but obviously it is possible. So because people have done it, and this completes the 4 steps of the energy forecasting workflow. And here are the challenges. So starting from aggregating the data from multiple sources, handling the big data. Okay, there will be different formats of data, different sizes of data. So how you can aggregate them, how you can handle the big data. Second, how you can clean that, how you can choose the best forecast model. Finally, scaling up to production. So all the steps have their own challenges. Okay. Now let's talk about a case study of forecasting the load for the next day, a day ahead load forecasting. So the objective here is like to use machine learning or deep learning models, so which are you can say a subset of artificial intelligence to predict day ahead load forecasting. And to address this case study, some of the data from New York ISO, NY ISO data was used, okay, which has data from different regions in New York. And then that data was used to through the steps like aggregating those things and finally using the model towards forecasting the algorithm development, and following that how it can be deployed further in the MATLAB production server or as an app, as a dashboard for the end users. So a very high level and end-to-end picture about what industry people are looking at when they are working on this problem of load forecasting. And the three challenges you see here are mentioned: data acquisition, pre-processing them, okay, which is the first and the second step itself, okay, acquisition of the data and then cleaning the data. Second is the hyper search to find optimal choice of forecast techniques, okay, so basically to find the best AI model on, if you want to say, or which is the best optimized version of model. And the third challenge is to deploy. So how you can deploy these trained models? What is the best way of deploying that? So these three challenges are there. And let's look one second. Let's look at the very short video of how the industry people want to make their application in terms of a dashboard. So here they can, it's like a GUI thing. They are selecting the different region and they can
convenient గా ఉంది
మాకు ఇప్పుడు వచ్చారు ఎన్ని చేశారు తెలుసా మేడం 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 విజయలక్ష్మి మేడం 1:30కి వెళ్ళా 5 వరకు
ఇంకా వస్తుంది.
Is there I can hear some voices, so if you have a question please feel free to ask, otherwise you can unmute yourself.
లేరని చెప్పి
ఇక్కడే ఉన్నా, అక్కడ ఉన్నా.
ఏమో కనిపించలేదు.
సరే సరే పర్లేదులే, ఎట్లా అట్లా అయిపోతే చాలు మనకి.
I request participants, please turn off your mic, please. IT support, please make mute the all participants.
Okay, thank you, Dr. Ravi, and yeah, thank you. So what we saw here, like a very quick way of how the industry wants industry people in this sector want their solutions to look like, okay, in terms of a dashboard where they can very easily see the predictions, and also they want that prediction to be true or close to the actual actual data, which will are predicted as closely as possible. And now when we are now we will look at these 4 steps, okay, one by one. So first, when we talk about the data itself, how to access and explore the data, so there will be these challenges like of different sources or different formats of data, okay. So how to make some sense out of it, okay. So that itself is a challenge. So let's see through this recording. So there is a screen recording here where we are showing the New York ISO data set. So that data set consists of the different types of data all together. And once we download that data, we can have a look at those and try to understand that better. And there can be some missing data as well in between. So for example, it will be marked as any n value, not a number. So for that, we need to also do or fill those kind of data, okay, fill those missing data. And if you see, these data have a timestamp, so it will be having the different timestamp from different years. And once it is loaded, we can also make use of some functionalities like data store. Okay, data store is something which can help us to point to a location where the data. So we have unzipped the data earlier. So it has been stored in a location, temporary location. Now we can point to that location and we can access the different rows and columns of the data instead of loading the entire data set, because there will be a lot of data there. So that's where we use data store. And then we also use functionalities like unstack. Okay, unstack is like a function which can, so you see there are different region names, okay, different locations. So it can unstack the location names and make different columns for each of the locations. Okay, so so that is important for us to analyze that particular variable further. And if you see here, there is a task functionality also here. So there is a task named unstack table variables under tables and timetables. So if you are working with timetable data and we want to do unstacking using the task, we can do that as well by using the unstack table variable task. So what it is doing, so it is similar to what we did in the earlier line you see, where we have used the unstack function. Here we are just giving the input, okay, the input table. We are selecting the New York ISO raw data here, and we can, after loading that into table, we can simply get the output table and have the unstacked table as the output. So this is the functionality which can, and you can also see the code. So it's using the same one line of function unstack with the correct arguments. So if you are not aware or aware of the function of unstack, you can also use some of these functionalities and do the things. So now you see the unstack table. There are different timestamps and different region names. The next is to visualize the signal. Okay, so after all the unstacking, there is stacked plot command. This will help us to visualize the data with the timestamp for different regions, and you see the load values. Some of them are in the negative range as well. So you see it's like minus 2000, and these are kind of maybe outliers. Okay, so people who are data analytics or who are working in the field of data analysis, they can very easily analyze this data, understand what are the problems here associated with it, and then they need to deal with that, or how to maybe remove those outliers and so on. Then, since we are working with timestamp data, we need to convert the table into a timetable. And finally, if you see here, we are checking whether this is giving us the correct value or not. So that is regular function which we saw, it was just it gave an output 0. So there are some problems with this data, and now the thing is that we need to do those pre-processing to overcome these challenges. So we very quickly saw a way of accessing a data which is already provided by in the public domain. Okay, so imagine you are working in a company who is collecting their own data. Okay, so that will have an additional step involved to it. But even when you have the data, just to load it and just to unstack it, there are certain steps involved, and just to see that, and finally how to use that, how to use the data to pre-process further. So now in the second step, we will talk about pre-processing and analyzing the data. So here, what you see here, so there is a statistics by Forbes, so which mentions data preparation accounts for about 80% of the work of data scientists. So out of this 80, 60% is cleaning and organizing the data, and there is 19%, or you can say, for collecting the data set itself. So if you're starting from collection, it takes 20% of your time. Then to clean it, organize it, takes 60%. So 80% of your time goes in this first step itself. So the remaining other steps require comparatively only 20% of time. So that is the statistics that we have from Forbes. And now when we talk about cleaning the data, so there are 3 aspects involved here. One is combining the data from different sources, and then removing the like poorly formatted files or the irregularly sampled data or the redundant data, because when we are combining different data, we want all of them to be maybe, for example, sampled at the same time. If we are taking data sets, if we have like 2 data sets, one which is sampled every day, another which is sampled every month. Okay, so then we need to understand, make a common sampling rate. Maybe the daily values that we have, we need to figure out the correct monthly values and just take those data. Okay, so we need to remove this irregular sample, and then we need to see where are the redundant data, outliers, or missing data, how to deal with them, and how to deal with big data, okay, which cannot be loaded very easily. Okay, so we saw that use of data store. So that's one way of dealing with such things. So in the second workflow, pre-process and analyze data. Here in the MATLAB window, you will see some of the techniques used to clean the missing data, replace it with an estimate, cleaning outlier, smoothing the data, and how to regularize the timestamps or how to sample it. Okay. Now, if you remember, this is the same task window, and if you go there, you will find more functionalities in the pre-processing sections. For example, cleaning the missing data. So in this case, we load the unstacked version of the data which was done previously, and there are different cleaning methods. So we have to choose the correct method, or we can also see which method is giving us better result, and we can see the output immediately. So with linear interpolation technique, we are filling the missing entries. There are like 25 of them, and here is the code for that as well. The red points are the missing entries. And finally, we can clear the missing indices. And next comes to clean the outliers. So we saw there were negative values, high values. Okay. So if we do some statistical analysis and understand the standard deviation or the maximum standard deviation, we can understand the threshold value, and we can put that threshold value, which will help us to filter out anything outside that. So if you see with a threshold of 4, the number of outliers is so many, 10, 1, 0, 1, 7, 5. Okay. So all the outliers outside 4 are being discarded. So this is how we can remove the outlier data and see the results through the task. Next, there will be noise in the signal also. It is being captured from different sources. So there is another task for smoothing the data. So this smooth data will take the input clean data that we had in the earlier step, and with the different smoothing algorithms like moving average or others you can try, we can get maybe filtered version of the data. And then the data is not regularly stamped. So we will use timetable and retime it to get the data onto a regular 30 minutes interval. So we want to have timestamps every 30 minutes. So with this, now you can see after every 30 minutes, we are having a timetable which is storing the data captured for all the 11 places. And then comes the step of data fusion as well. Okay, so data fusion means if there are other parameters like weather. Okay, so we need to understand, we need to fuse that as well to the original data. So, so using the synchronized function or using the synchronized live task, we can send the arguments of 2 different data together and then fuse it. Okay, because both will have both the data will influence us in the correct decision making of the models in the later stage. So this is how now we have increased the size of the data set by fusing it. And then modeling the load forecast on a zone. Then we can select a zone and we can go ahead for modeling the data. So when we are going ahead for modeling the data, now comes the step before we go for machine learning, which is known as feature extraction. So we need to find the features like the temperature and other things, and we need to correlate between the different values. And then once that is ready, we can move ahead towards the third step. Okay, so you just saw a glimpse of the challenges and the steps which are there to address the challenges with respect to cleaning, pre-processing the data. And once we have the features, now comes the third step, which people who are already working or have seen worked on many projects related to MLDL or even new to it will be more excited, because here they can now experiment their features to see how they are performing. Okay, the most of the job will be done by the models here if we provide them correct inputs or the correct data. So when we talk about ML, there are different ways like unsupervised or supervised methods. So supervised methods will have label data, and it can be either a classification or a regression problem. So in this case, if load forecasting, we are trying to forecast some value, it's a regression problem. If you're just classifying some categories, it can fall under a classification problem. And deep learning is a subset of machine learning, okay, which is like a more complex model, okay, and it typically does not involve a feature extraction step. So there are two primary difference here. So in machine learning models, they will be less complex, which will take less computation compared to a deep learning model. However, we need to do some feature extraction, feature reduction if possible, and feed those limited set of features. However, for deep learning, we can make use of complex models, but we need a lot of compute power. And those complex models can automatically extract useful information through their initial layers. So that's the primary difference between the two workflows. Now, the challenges in step 3 in terms of developing the forecast models are, maybe somebody is good in this or have some understanding of machine learning, deep learning, but they have the lack of data science expertise. So to come to this point, there are many things related to data that we just saw. So that requires a little data science expertise, how you can get those features out of it. And feature extraction, how to transform the data to best represent the system. Okay, again, it will require subject matter expertise. So there is no right way of designing features. So there are different statistical techniques. You can say mean, standard deviation, median, or so. But from application to application, you can, from the literature, you will find out which kind of features will be suitable for what kind of data. So how to get the best out of it, and then how to select it. So if we have a large data set, okay, or a large number of features, then it will be difficult for the machine learning model, okay, to deal with that. So that is one thing. The second thing can be the large number of data features may have some redundant or irrelevant things. So we need to select that, the useful things out of that. So that is what feature selection is. So what are the best attributes or subsets to use out of all the features we have? And then we can go towards the model development, where we are using these machine learning models or deep learning models, and see what is the time required to conduct the analysis. So here you see I'm not a data scientist, but how to look into the AI development. So there is a set of apps. So inside the app section under machine learning, deep learning, from classification to regression. So here we open a regression learner app because we want to predict the load value. It's a continuous time value. So we can load the model data, the training data, okay, that we have, and then we can select the response. So this becomes a supervised regression learning method, we can provide the type of validation for it. And then through the app, we can first of all visualize the data, the load versus the record when it was captured. And there are a bunch of different models. So if you are not knowing which models to try with first, you can get started by selecting all the models. And this is like an auto ML. If you are selecting all models, it will obviously take a lot of time because it will get trained through all the models, and automatically you're trying to see which is giving you the best result. So once you start training, depending on the number of cores you have in your computer, you can use the parallel compute, and the models will be trained parallelly. And the best model will be highlighted with the root mean square error, whichever is having the least value. So, and then once the model is there, you can think about optimizing the model further. So in this case, fine Gaussian SVM gave us the least root mean square error. But if we want to optimize the SVM, we can go to the advanced settings. And here there are the 3 types of optimizer: Bayesian, grid. And usually grid optimization will take more time. You can go with the Bayesian, and you can choose the type of hyperparameter values. So the hyperparameter values related to the model. So in this case, SGM model will have these hyperparameters. So, and then you can simply train the optimized SVM model. So now you see, because it will optimize for different number of iterations. Okay, each iteration is choosing a different set of hyperparameters, and whichever is giving us the best point, okay, will be highlighted. The best point hyperparameter will be highlighted in red. So that way we can train or try to find out which model will be better in this step, and also optimize it. Now, suppose if you can't identify the features in your data, so that's also a challenge. Then in that case, the other approach can be use of the deep learning method. So in deep learning method, we just need to deal with the raw data. We can normalize the data first, and after that, we can use those data with a deep learning model. So this is the time series data. So first of all, you can do some splitting on the testing and training part. And there are different deep learning models like LSTM, CNN, GRU. So in the same section, you see the second app known as Deep Network Designer. Okay, so this is the one which will help us in developing such or using such deep learning models. So a deep network designer is, you can see there are some predefined models, but you can also make a blank model. So in this case, a basic blank LSTM model is being shown. So where we take an input block, a sequence block, which will take the time series data, followed by the LSTM layer, and followed by a fully connected layer, and finally a regression layer. And then we join the connections from the input to output. We can just auto arrange, fit it to view, and then each block will have its own parameters. So depending on the type of data, the dimension of data, you can change the input size. And here you will need knowledge of LSTM, so how the different layers are connected, what are the parameters you need to change. And once you do that, you can quickly analyze the network to see how many layers are there, whether you're getting any errors or warning, and then move further towards exporting and generating the code with parameters. So this will generate you a live script with the initial parameters of the layer that you made. So this layers variable is the 5 layers that we just created. Okay, taking the number of features 528 as input. Then we need to create the training options. So we need to put the options, and using the train network command, we can send the arguments, the training data, the training labels, the layers, and as well as the training options, and start training the model. And once we do that, we can see the graph for the loss as well as the root mean square error. So this is for 100 epochs, and it is done in a single CPU. And that way you can use deep learning models, okay, for the work. Now, if you see, there are many more apps. One is known as the Experiment Manager. So this is another useful app if you have to go further to optimize your hyperparameters. So we saw a bit of optimization in the regression learner app, but for deep learning or for any in general, for any optimization problem, this Experiment Manager app can be used, where you can mention the different hyperparameters in the hyperparameter table. So like the learning rate or the epochs, you can put those values here. And once you put those values here, you see you have done different set of experiments, and you can compare between the different RMSE and different laws. So this is how you can optimize the deep learning models further as well. Okay. Now coming to the next slide. So this will give you a high level idea about what to choose, okay, or what are the advantages, or what are the things we need to consider when we go for machine learning or deep learning. So obviously, if you have a good domain knowledge, and then you can extract better features, you can go with a machine learning technique, okay, to start with those features. On the other extreme, suppose you have a lot of raw data and you don't have that signal domain knowledge as well, but you have a lot of data, then you can try using deep learning methods. However, it will require more amount of compute power. You will require that because the model complexity is increasing when you're going with deep learning methods. So these are the two extreme things, and based on that, you need to decide when to choose what. Okay. Then the fourth step is on operationalizing the models. And when we talk about operationalizing the models, so there are a bunch of workflows, like one falls under the coder products. So how, if somebody is targeting some embedded hardware, so some of the coder tools can generate the C, C++, HDL, PLC, or CUDA code. If we are going through the MATLAB compiler workflow and we want to use the algorithm in the form of a app, okay, web app, in the web app server, we go through that. Then there is a MATLAB compiler SDK workflow. So often in enterprise systems, so there will be different frameworks like C, Java, Python, .NET, with which most of the systems are already made. And now if you have to add a particular addition to that, then this MATLAB compiler SDK workflow will help to integrate that with the existing system. Okay, and similarly, there is a Simulink compiler which deals with the Simulink models. So these are all the different high-level ways, and this slide shows you for deploying your models. And with that, I will try to discuss or summarize what we have discussed so far. So we talked about aggregating the data from multiple sources, handling the big data, talked about pre-processing, cleaning the data, and we also saw ways to choose the best forecast model. So whether machine learning or deep learning or ways to optimize it. And finally, we just saw how we can scale it up to production in terms of deploying it. Okay. So some of the key takeaways which I would say is pre-processing is no more time-consuming process. So obviously, for the first time, whoever is working, it will take some time for anyone to understand the process. But once that process is done, it will save a lot of time. So it's not many things are getting automated. If you see that like that, so that way you can save a lot of time. So it will reduce your efforts. You can reduce your efforts spent on pre-processing. And with the tools, you can enable the domain experts to do data science. Okay, so those who have good domain knowledge can do a lot of good work in terms of analyzing the data, getting good feature extraction out of it. And advanced analytic techniques are there, which can be applied in terms of AI/ML. And MATLAB analytics can run anywhere. So that's the third step. So mostly when we are talking about deployment, so it is possible to operationalize analytics to enterprise systems and integrate with dashboards. Now, after this talk, what I will do, I think I will share this deck with Dr. Ravi as well. So there are some links here I have provided. So these are very useful links related to the topic. And while preparing for this talk, I myself referred to some of these links because mostly I worked in AI for different applications, but not specifically for the energy forecasting. So this was a new exploratory thing for me as well. But these are very nice resources in terms of you will find some MATLAB codes, you will find some recording, some documentation, and some technical articles. Okay, these are these 4 links here. And then there are some courses also. So if you know about the MATLAB training or MATLAB on-ramp or MATLAB Academy, so there are different courses which are there. Some of them are free in MATLAB Academy. So you can earn, or some of them are in the website like Coursera related to this data science and MATLAB specialization. So if you want to have a deep dive into these things, so you can try to explore this Coursera course also, a practical data science with MATLAB specialization, where you will learn more on the front of just dealing with the data sets, different kinds of data sets, okay, which will help you to overcome the very first step about data. Then that was with respect to learning. If you are interested to give projects to your students, the PhD students or the BTech final year students or the MTech students, so there is this MATLAB and Simulink projects page. It has a list of projects in different industry sectors, and there is one on this topic of sustainability as well. Let me see if I can show you that page. So in Google, if you can type MATLAB and Simulink challenge projects, so this will be the GitHub page, which will have different problem statements. And here you see, so there are different trends from AI to wireless communication. and especially sustainability and renewable energy. It's a very important topic, so it has challenge also. So if you are working on problems under this category, you can let's see what it says. You can get some additional rewards. So you get a chance of winning some monetary prize as well. Okay. So how it works? So if I just go to any of the link, I will you can see different problem statements. So for example, intelligent energy management system for smart grids or solar tracker control simulation. Okay. So let me click on this one. This one has both machine learning for wind turbine predictive maintenance. So once we are inside the problem, we can know more about what this is. So we want to improve the reliability of wind turbines by using machine learning to inform a predictive maintenance model. So we can monitor the health of the wind turbine. That's the problem. And you can quickly go through what are the things needed for this. So you need to understand, you will be learning about Synscape, which is the physical modeling inside Simulink. And these are some of the background materials, and it's set at a difficulty level of masters. So with that, you can decide whether this is a good problem for your students, and then the student can make a team. They can fill this with the project advisor name, and we get an information that this particular team is working on this project. And finally, if you are able to complete this, if you just have to make a GitHub upload, and once that is done, you need to just let us know. Then that project will be evaluated by the team, and if your project is evaluated well, requirement is satisfied, you will receive these rewards. Okay, so this is evaluated directly from the team in which sits in Natick, and you can also see some of the current project submission in different problems from here. Okay, so this was about the projects page. Now, yeah, so that I'm almost close to concluding the talk. So here you will find some more links in terms of recordings, tutorials, and open exchange community like MATLAB Central. Okay, so some of the resources in the previous slide are from a file exchange, okay, where you can find useful getting started resources. Then these are the on-ramps. Now there are many more. This is a slightly older slide. There are like close to 59 or close to 60 plus courses. Let me just show you that as well. So if I type MATLAB Academy, then this link will take me to the matlabacademy.mathsworks.com. Oh, it has increased. So it was 59 couple of months back. There are 78 courses out here, and 24 are on-ramps. On-ramp means introductory courses. It will take 2 hours of your time for each of the course. So you can quickly have a look which are the relevant ones for your project, and you can ramp up on these courses. And also some of the things that we saw today in terms of the apps, ML or DL, you will find in these courses. And if you want to explore the full courses also, it will take more amount of time, but if you are sure that that will help you in your project, you can try to just filter with respect to the application and workflows, and you will find the courses like this, machine learning techniques in MATLAB. So it has a learning path. It is divided into 4 courses. So if you go further, you will see the first section is of 2 hours, which will just focus on classification methods with ML. Then it will focus on the regression methods with ML. So especially today, what we saw here, it was a regression method. So if you do this, you will be able to relate it better. So what are the regression methods? Then there is cluster analysis. So cluster analysis we didn't discuss here, but if we are talking about unsupervised learning, we are talking about clustering where we don't have any labels. That will talk about that aspect. And the 4th aspect is equally important, how you can reduce the dimension. So like PCA, there are different methods, dimensionality reduction techniques. Now, if I just click on maybe the 2nd course, if you are interested in the 2nd course and not the entire, all the 4 courses, you can just quickly complete these 2-hour things and you will have a fairly good understanding of some of the linear regression models, the SVM decision tree, and how you can do some regression analysis on that. Okay, so this way you can make use of this MATLAB Academy for learning and the MATLAB and Simulink project page to give your students or UG students, final year students who are searching for projects which takes around a semester time to work on, to explore some of the industry relevant projects. Okay. So with that, and there are some, if you are interested further in instructor-led training, we can get you connected to the training team as well for better experience. And MathWorks is the company which has this MATLAB and Simulink software, and we are always happy to help you if you are working with our tools, and if you need any guidance, you can feel free to let us know. And with that, I conclude my talk. If you have any questions, let me know. And Dr. Ravi and Dr. Della ma'am, thank you for the invitation. I hope this was useful.
Yes, sir. It is
Thank
very
you so
nice
much.
session because in chat box, the participants, they are giving the feedback. From that feedback itself, we can say it is a very nice session. So let us give the chance to the participants. If anybody having the queries or any doubts, or it may be any help from the MathWorks, you can interact with the resource person, Dr. Anand Mukhopadhyay. Please over to the participants.
Also, my mail ID is here. So in case once you are exploring more, if you have any questions later also, you can drop a mail and I will try to respond whenever I can and guide you on those things as well.
Participants can unmute and directly interact, okay, with the speaker if you have any doubts.
Okay, I see one chat. Please share the code.
Yeah, sorry.
So let me just show you one of the links that will. So let me just, so this particular slide, so that's the reason I shared this. So this is like a file exchange entry. So like data analytics with MATLAB, and the demo files for these historical data analysis can be found here. So you can download these. So it has already a 4.1K download, or you can also open it and save it in your MATLAB drive. And so this will be a good starting point for you to understand about the data. So some of the things that I was discussing about the New York data, so files and codes are all mentioned here. So you can have a look at those, the data analytics load forecasting case study, and have a more better understanding of how one can go to creating web app as well. Okay, starting from loading the data, aggregating the files, format the data. So this is all publicly available in the file exchange place. So it's a very useful place, not only for this particular thing. If you are searching any other thing in your field, if you type file exchange, MATLAB file exchange plus that topic, you might find some relevant code which may be uploaded by anyone. So in this case, this is uploaded by one of our staff. So it is like, but it is, if it is authenticated, but if it is uploaded by someone else, and if you see it has a lot of downloads, you may also try to explore that. Okay, so it's a very useful place, the file exchange resource. Next time, about the session recordings, I think the sessions are being recorded, and I think I'm not sure when it will be shared or how it will be shared, but Dr. Ravi or Dr. Della might be able to answer that.
Sir, we will share by email, sir. We will share by email.
Definitely, sir. Give it us. We will share by email. No worry about it.
Okay, so that will be shared, so do not worry about that, as I have received a news.
And also, we will upload these sessions in our website, Tribetic Time website through YouTube. No problem. They can check.
Any further doubts or from participants? I think, sir, yeah.
Compared to previous sessions, let I have one point, Dr. Anand Mukhopadhyay, sir. Like yesterday, up to yesterday class session onwards, the participants, they're asking that they are more focused on the climatic adaptation and all. So from these climatic adaptation, how they will collect the data set. So where exactly is it? Any sources are there to collect the data set? Because yesterday session also, some of the research person, they mentioned they given some websites, but you are very familiar to the math works. So if you want to analyze the particular area or particular place, so what is the data set, or any tools are there to get the data set, real-time data set?
Okay, so exactly, I also have to do a bit of search on this, but on a high level, if I have to say, so either there will be public places, so where somebody has already made a setup which is collecting the data. Okay, so maybe if somebody is using those IoT ThinkSpeak channels, so there will be some public channels which is collecting real-time data through some sensors which is placed in a certain region, and people can use that data to work to do some analysis. But if you have to do it for your own problem or for your own region, then the first thing will be to make that setup. So for that, you need to have some knowledge about the type of sensors, maybe a sensor which is calculating the moisture or the pressure or the temperature. Okay, and how that sensor can be connected to some of the hardware devices, maybe like Arduino or Raspberry Pi, which will have some Wi-Fi component, which can collect the data and also send the data to some cloud places. So obviously, this is not if you have to just starting, this is not a trivial task. You need to have some, and you need to study about all these things, how you can do those integration. But if you just want to do analysis, it's better to see what are the publicly available data sets. So in today's talk also, it was just taken from one source. So there may be many websites where some data sets are already loaded and it is updated from time to time. So that you have to search.
Actually, most of the participants are from faculty members. So they are working in various institutions across the India. So what they are thinking, what they need is, they want to do something work on related to some AI, ML or climatic adaptation things. So they are worried about how to collect the data set. Because
how to collect the data set?
Because you are from industry, we are from some various reputed institutions. We may have the type of access because our scholars are there. They are doing the things. But in the private colleges or in some universities, their faculty members, they are very intellectual. They are having potential to solve the real-time problems. But they should have a particular platform to get the data set.
Correct.
If the data set is there, and also the another problem is there, if they're having data set, but they are applying some ML models or DL models like that. After getting the output, whether it is they are training the model. From the model, they are getting some accuracy. But whether it is exactly correct or not, because they are not validating the data set, input data set. So it is a big challenge. If the data set is, we can't say whether data set is correct or wrong. Sometimes we cannot predict. Suppose a real-time data set we collected. Can we say that it is a exactly correct data set?
So if I understand the question correctly, so if we are after collecting the data set and after getting a good accuracy in after using machine learning models, we are not sure whether the data set that we collected was correct or not.
Yes.
Yeah, so that is always that's a very good question actually. So that is where we require that domain knowledge. So that domain knowledge is or domain knowledge will come from literature survey on that problem. So when we are collecting data, how we are collecting the data and how the data will be fed when we are actually using it on a already trained model. Okay, trained model will just take the data, it will pass through the layers and or pass through whatever mathematical equations are there, and it will give us the result. So that has to be similar. And secondly, when we are collecting the data, today we saw about some of the ways of pre-processing. So what are the irrelevant noise and other things, outliers? So that is very important. So only after that, if we train a model and then we have to do test the model again. So we may not get a good test accuracy. Then we have to figure out where the error is. So training the model and getting a high validation accuracy is okay to that extent. But after that, we need to also use it on some test unknown data. But it's a challenge. So that is not a very trivial thing. It will require some domain knowledge, I would say, for addressing it in a better.
One more thing, the last point from my side. Like our math works, if a new person, for example, electronic person or some other interdisciplinary person, want to do the work on hardware. Like nowadays, we got the machine learning kit in India. Like we can say Arduino teeny machine learning kit. Small kit I'm talking. Like that, do we have, like in our VLSI domain, we are talking about FPGA, CPLD like that. So do we have any type of hardware kits are available in the market? If they are available in the market, do we have any type of hardware interfacing is done in maths work, which is related to machine learning things? Is it what type of problems we can solve from our MATLAB? Okay.
So there are two things here. So one is before the machine learning also, there is one thing known as hardware support. So I will just post the link here. So I will just share the screen also. I can.
Fine, please share it, sir, because most of the members, I could say one point. Some of the institutions, they are working with, for purchasing the MATLAB itself, they want to work with Scilab, something like that, Python like that. Do we have any facility to work on hardware with MATLAB? If it is there, then what best we can utilize? Because we are talking with respect to research aspect. If somebody will be contribute something amount which is related to an MATLAB purchasing the kit with and all, then what way they can do the research? Because in some of the organization, they have to do some publications and all. It's a mandatory. So for doing the publications, they need something data. It may be hardware, it may be something. Publication has to come from their innovation. That is a different point. But if any hardware is there, any real-time thing, real-time hardwares are there. Simply, if you put like what we can say that if we want to measure a body temperature, SpO2, simply if you put a device, it will be getting the value. Like that, if you such type of any hardwares or predefined hardwares are there, if you give some data set, it will be gives some type of output, like our teeny circuit like that, teeny machine learning kit like that. Do we have any like that? If we have, what best we can utilize that?
Okay, so to answer this, so our is a software company, so we don't have our own hardware, but we try to create hardware support packages for many of the third-party hardware vendors. So this is the hardware support page we have, where you can see some of the vendor names, popular vendor names, and you can also search with this filter. And then you will have some more information about what are the different capabilities of these hardware. So there are two things mainly. One is to collect the data itself, the live data streaming. So what are the different kinds, like webcam or some microphone, okay, or some instruments. So you have to, this will help us to collect or stream data. And second is target hardware. So for that, we need to generate or have the code for that target hardware. So what are some of those hardware for which we can generate the code and target those things? So and then like the thing you were mentioning, this is basically will be a very good thing for project-based learning with hardware. So if you have any hardware already, or if you are planning to procure some hardware, you can explore this page, and then you can go further inside any of the hardware. So if I go under Arduino, then it goes to another page where it will show me different types of Arduino and what are the support packages. So Simulink support package for Arduino, it will download the support packages where we can use the Simulink models, okay, to do certain projects. And then there is a list of the supported different hardware. So the basic one like Arduino Uno, the classic board, then the nano boards, which will have like it can be done for IoT applications with Wi-Fi enabled inside nano boards, MKR boards, and other things. So there are so many different types of Arduino boards which are supported, and then from MATLAB, if you want to use Arduino, what is the MATLAB support package, and some of the related examples for that. So from each of these pages, you can explore. Similarly, if I just go back and click on another hardware, AMD, then I am getting some more information in terms of using the AMD hardware like FPGA SoC support package for deep learning SDL toolbox. So if I go to this link further, then this is a support package which is supporting one and to these two particular hardware, ZC706 and ZC102. So if you have such boards, or if you are planning to have similar board, then you can use this support package to run deep learning inference on the AMD FPGA SoC boards as well. And again, it will have some getting started resources, and getting started in the sense, if I go here, it will be a MATLAB file, and you can just copy the command and you can run it in the command prompt. So these are the lines of code. It is doing a digit recognition, okay, on a target board, and finally it will tell predict the number and give us it will have a faster inference time, so you can get the deep learning processor performance through this. So like that, this is a getting started example. So that way you can explore. So whichever hardware do you have to basically see whether that particular model is supported or not. Not all models are supported, but whichever are there, that will be listed and updated in the hardware support package page. So which is the this page, hardware support plus MATLAB.
Right.
And
Yeah,
if you
very
have decided on the hardware, you can always drop a mail to us. We can do a search for you and help you with some of the related things, so that it becomes easier for you.
Yeah, fine, sir. Thank you so much.
In fact, a mobile phone will also be supported if you have an Android or iPhone. So that is also hardware. So you need not purchase anything external. You can try with your mobile phone how you can use it as a sensor to capture data and like that. I think you have tried that once.
Yes, sir. Already I tried, and I
Yes.
implemented approximately 5 programs on that.
Yes.
5 applications also I implemented. I given some tasks to the students also for the digital communication, digital signal processing. Yeah.